so we can start? Okay. Well, it's a great pleasure to follow up Jason's talk with a panel now to discuss institutional crypto economics. Of course, we've got Jason, who you've already met and already heard some of the work that he does. We also have Alex Sums. So Alex is an associate professor in the Department of Commercial Law, University of Auckland. She's recently become a bit of an expert on blockchain technology and its relations to regulation and law. So it'll be really interesting to hear her take on this space. And we've also got Robert O'Brien. So Robert's a software alchemist. That's the official bio. So he designs. He's a designer. He's built distributed systems. He's also been a financial cryptographer. So he's worked on high-performance, reliable transaction systems from investment banks, insurers, financial market data providers, and trading venues. And he's got an interest in innovation in general. We heard about some of the things he's doing with in Tauranga, for example. So really great to have you three here to talk about institutional crypto economics. Actually, so how about we do that? Since we are being recorded, do you want to quickly tell us what institutional crypto is? The audience here, of course, has already heard that take, and then I might ask you guys to give your response, perhaps, to Jason's talk, which we heard this morning.
I already have a question.
Oh.
My question is the name of Robert.
Okay.
My program says Robert Holt, but you said Robert O'Brien.
Yeah, it's Robert O'Brien. Yeah.
Yeah. I just want to make sure it's the same person.
But I'll go by Holt.
Yeah.
I don't know who that is.
It's an identity issue. Yeah.
Okay, messed you up.
Okay. Anyway, so.
All right, institutional crypto economics. So first thing is we made that word up, that term. This is a name that we've given to something, which is one of the first things that happened in the blockchain space was that a whole lot of computer scientists reinvented modern game theory and economics, and they did it by having to solve an incentive. How do we design incentive these mechanisms? So people like Vitalik Buterin and others got out some game theory textbooks and taught themselves economics and built all these things, and then they called the thing that they just built cryptoeconomics. And that was economics applied to the design of consensus algorithms and mechanisms. Institutional cryptoeconomics is what does an economy look like when the base infrastructure of it is made of blockchains, is made of that. So we wanted to sort of emphasize this idea of the underlying theory that's coming in is institutional economics applied to an economy that all of the infrastructural layers that are normally provided by government and so on are blockchain. So institutional, that's sort of my sense of what institutional crypto economics is. And we sort of think of this as institutional crypto economics as like a new field of economics, like growth theory, in the sense that it's trying to understand the economic principles of an entire economy through the lens of this fundamental technological shift.
Yeah, okay. It gives it's a very short, pithy take on your talk, I guess. Alex, do you want to perhaps react a little bit to what you heard this morning and maybe picking up on your own perspective on crypto economics?
Yeah, just one thing, when you said recently with blockchain, because recent is because it's so new, so I've been doing it for over 3 years, which might seem recent, but that's almost like a lifetime.
That's a lifetime, yeah. And actually we can pick up on that later, because we're talking about the pace of innovation in this space. Yeah.
Actually, just on the institutional economics, but I guess part of it also came from taking the new institutional economics as well.
So institutional is shorthand for new institutional. In the Ronald Coase, Douglas North, Oliver Williamson, Oliver Hart, sort of in the sort of the modern sense of what are economies made of? They're made of resources and technology and institutions. And the quality of institutions determines the quality of economic growth and output.
But also, it's an extension from that, because it's not just using that, and it's not just a reduction in transaction costs. No. It's what that allows us to do.
No, and the new institutional economics is a lens where you sort of look at an economy and you see governance and organisation, and firms and markets, and ask the question: why is this economic activity taking place in a firm, or is that economic activity is taking place in markets? And the answer is transactions costs. Right? So this is a technology that automates a lot of or dramatically lowers or shifts transactions costs around an economy. Therefore, the lens, the right branch of economics to understand what we're looking at here is new institutional economics.
I agree with all that, but my own work I'm going down, I guess you might call micro, into the actual institutions themselves, into decentralised autonomous institutions. So instead of the notion of the firm sort of set up in a certain way, is with DAOs, decentralised autonomous organisations, and looking at the governance and that level, because that, at the moment that's what's sort of, it builds into the broader thing. But what I find very interesting is you get these, dare I say, normally young males who are coming along and saying, this is all new, we can do whatever we want. And it's like, no, people act a certain way, and they're slowly having to learn that. And it builds just the commons, which we had a great explanation of before. It's also the new voting systems, and it's also stuff that has come along very, very recently, like quadratic voting and things like that, and things that people could only ever do in the past, or theorise about them. For example, futaki, no one knew that. It never actually been used, had it? But now that's being used. Prediction markets within DAOs and other situations, and also things like liquid democracy. So that's another one. So it's actually a combination of a whole series of different things. So I'm taking a slightly narrower view at the moment.
Well, I basically totally agree with the lens that Jason's applied. I felt, having been aware of the technology for quite a long time and all its predecessors, and largely the area of financial cryptography is an umbrella term for a multidisciplinary area which brings economics, law, privacy, computer security all together to economic activities. And the poster child of that field has become the likes of Bitcoin and therefore blockchain. So it has basically explored a lot of the ways we use rules, obviously in the context of computer systems, to define what actually happens. So game theory, for example, has been used in computer systems for quite a while. A number of the protocols of the internet in terms of solving optimization problems around routing, traffic routing, uses game theory, or more specifically takes a mechanism design view and applies it to protocol design. What was quite significant about this Nakamoto paper, the Bitcoin paper, was that it actually brought all these different disparate areas together in one cohesive whole, and it was the whole aspect of it that sort of ignited, hey, we can solve these problems that were considered really, really difficult before by bringing all these things together at once, and then that sort of ignited a whole lot of innovation in terms of that space. But for me, it's always been about, Coase's theory of the firm around the implications of transaction costs and trust, etc. By lowering those, what would it do? And so the interesting questions became, well, what and why? And the lens, therefore, is to look through from an institutional point of view, which is like what tools can we use for the purposes of governance? In effect, from a common standpoint, the way I view it is kind of a market for rules. Yeah.
So one of the questions that we had that came up during Jason's presentation that we kicked for touch for the panel discussion was around this evolution of the technology. I think it was you, Alex, that said it was a Model T Ford 3 years ago, and now we're driving a Lamborghini.
Well, more than 3 years, but that's equivalent to, because Bitcoin is actually quite, clunky and cumbersome, but it works, and it's still working, but now people are over here.
And that's the concern that some people have around the number of CPU cycles that's being spent on the mining and the cryptography side. Is that still a concern?
So two parts to this. So first off, just establishing a baseline here in terms of this idea of the fastest moving technology we've ever seen.
Yeah.
It's important to look, not so much is that true, is it not true, that's an empirical question, but look at the reason why that is. And first of all, it's made of open source software. So there's no patents blocking, slowing it down, as anyone can come in. So the entry barriers are just low. Secondly, it's happening simultaneously in every industry. So it started in fintech, but lots of the progress has happened just as every sector. There's not a single large company on earth that hasn't got someone in it somewhere working on how do we apply this in our sector. So that everywhere. So I get to travel around a lot, and right now the most exciting place in blockchain is China. They're just putting huge amounts of resources into it. So you've got almost very low barriers to entry in every single sector, in every country in the world, working. So we've never seen R&D like this before. Normally R&D starts in Norway or somewhere in Rome, and then spreads, it diffuses out. This is one that is just happening simultaneously in every sector, in every country, just with very low barriers to entry, and also low financial barriers. So I spend a lot of time in the sort of Bay Area, and half of all of the venture funds there are crypto funds. That might be a slight overstatement, but it's not that much of an overstatement. Like all of the smart young kids are working in crypto right now, in the same way that all the smart young kids in the late 90s were working in .com. Right? That's what's happening. So that's why it's moving so fast. And we've never seen this combination before. And
what's the metric for movement? I mean, what are we saying?
Well.
Changing?
Exhausted?
It
is moving.
It's just entry, I would say. And so,
Right.
I wouldn't measure this in, show me the shipped product. And, that's a bad measure.
Yep.
But if that's what you're trying to measure, it looks like it doesn't have, it's not like, look at all the mobile phones and use the thing. But just the amount of time that's going into working.
Yeah, just on that is that when the internet took quite a long time, and it was a lot of people working part-time, working at night on their thing.
Yeah.
Now they've got the best people work full-time from a whole range of things. So and you've got the internet off the backbone of it as well.
Yeah, because that's the other thing as well, is that this is a technology, blockchain is a technology that exists on the internet. If there's no internet, this doesn't exist. Which is, so first you have to have digital, then you have to have cheap computers everywhere, then you have to have so the diffusion cycles of sort of just basically digital have gotten to a point now where this can come in fast and everywhere and so on. So that's the reason, right? So what that does is it just predicts that whatever you think of as how long it takes for a new sector or a technological shift to happen before, it's going to be faster this time. And the main barrier, the main thing slowing it down at the moment is regulatory uncertainty, not R&D investment. It's not slowed because for a market failure, if only we could get more venture capital finance in the space. That's not the reason. That's swamped with that. The main barrier is I don't know if I'm going to end up in prison, or I don't know, or for what reason. Right. So it's that sort of regulatory uncertainty that is slowing down subsequent corporate and institutional adoption and so on. And this is why we spend a lot of our time in Aukland Research Centre just explaining this with sock puppets to politicians. In a kind of, it's not scary, but it's definitely coming. You can ignore it, whatever, but it's still happening.
And I just think on Shaun's point is that Bitcoin, yes, it uses massive amount of energy, electricity, but the newer ones do not use that. That's the thing.
We're
on sort of generation 3 already of this sort of stuff. And
you can look at it if you so going through the cycle of what happened with Bitcoin from when it was actually originally released to the slow sort of adoption or rapid adoption of it, and that's somewhat mirrored in the adoption of the mining process itself to begin with, which was largely, I could mine quite literally, because I did, on my laptop for Bitcoin and get 50 coin a pop, really easily, just on a dungaree old laptop at the time. But the rapid cycle in terms of the miners developing into using GPUs, and then the emergence of large GPU rigs that then appeared, and then you got the emergence of FPGAs to really try and speed that up, and then they got bigger into bigger clusters, and then you started getting the ASICs the specialised silicon chips for doing just one thing and one thing only. And then they just got bigger and bigger and more efficient. And because the incentive here was the cost of electricity.
Yeah, so at the same time as that sort of was going down that sort of technological diffusion, just ramping up in power and hash rate,
Yeah.
you also saw the mining sector move around the world chasing cheap electricity.
Cheap electricity.
So, no one mines in Australia now unless you're basically stealing it off your employer. Then it went to Iceland for a while. Then it went to China. Then China got too expensive, and we don't really know where it is. But most of it, I think, the intel I'm getting is it's in Mongolia now.
Quite possible.
Yeah.
I haven't been tracking.
But it's just this globally mobile computational engine, distributed. It's not not a single
that
thing.
kind of reached its threshold in terms of the silicon fabrication process, getting down to, I think the last ones were in the 22 nanometer, it might be. So that means you hit a ceiling in terms of your efficiency from proving just how many hashes you could do. And so then you started people starting to look at more efficient algorithms. So saying you had emergence of other forms of lotteries going on and other forms of incentive mechanisms to reduce the computational footprint but keep the same sort of property.
And those are just the public blockchains. The private ones don't need to use mining.
Yeah, right.
Yeah.
Yeah.
And so you can sort of track all of that, and you can see it evolving over time. Probably the measure for me personally was looking at it, stuff that I never expected to hit kind of notionally mainstream in terms of the use of cryptography, the use of distributed or consensus mechanisms. Mark and I were just talking about formal methods yesterday, and the fact that now that is becoming an important practice within this industry. I never expected. Really did not. So these are areas that are usually put off to the side or just in the academic domain as a curiosity for computer scientists to work on, all of a sudden become of significant import to this area, which then elevates it overall.
You've got other measures there's lots of ways you measure this. One that just amazes me is that here's a technology that didn't exist 10 years ago. All of the top universities in the world now have research centres in this space. They've got courses running. It's a
we're
thing
laughing because
it's just exploded, literally in the past few years.
Yeah, except for University of Auckland.
But just in Australia, Curtin just announced one 2 weeks ago. QUT put one up. They're just so that's demand driven, right? So there's demand from students. Just we want to study this sort of thing, and just the speed at which that happened, right? If you just think of other things like nano and so on, there are research centres and those things, but it's decades after the foundation.
What I would suggest, even though there's rapid innovation occurring within the space at the moment, it's by no means there's still a huge amount of uncertainty, huge amount of uncertainty about this, in terms of how the industry overall will evolve, what will become the dominant model of things, but what you're seeing is lots and lots of different experiments, and progressively it moves up. So I talked about, just to begin with, you had an explosion of different, basically taking the code base of Bitcoin, tweaking a few parameters, and creating a new network. So Dogecoin and things like that sort of emerged, and Litecoin emerged. So you had effectively the same sort of properties that were largely the Bitcoin system, and they just tweak things and you get establishment. Then you sort of move up a layer in terms of what's been going on. So Ethereum came along and effectively found what we would argue is a killer.
It was only 4.5 years ago.
Yeah.
It's incredible.
Found the killer app in terms of crowdfunding. It had already been done. Bitcoin effectively was a form of crowdfunding in its own right. And there have been other projects before Ethereum that have been using Bitcoin to do crowdfunding in this area. So one of the really interesting aspects of this is that the value and the incentives, etc., are intrinsic to the networks themselves. And so that means a lot of the innovation and stuff can actually be completely open, because just merely by contributing to a network in some capacity, even if that's me speculating on crowdfunding sort of things, or the tokens as they're called, I'm actually participating in the adoption of that network. And that in itself is a valuable sort of act. But by actually contributing code to the network and stuff, I'm building that stronger network because I've got a way to capture that value and interest. In a sense, it's like I can be an inside trader by contributing code.
And also, just one thing, we had a conversation before about these open source, it's a public good, but who's funding it? Well, that's what some of these blockchain systems have actually done. They've got their own treasury. And so that is actually paying people to develop it, which was not,
So
hasn't happened before.
one of the things we just, research team got actually fascinated with this because of these weird things that you're sort of seeing. Is this that here you've got code that has got properties of entire nation states and governments. Like it's built its own infrastructure, its own monetary system, its own enforcement mechanism, its own treasury, and this is a thing that a bunch of people hacked together in an afternoon. They threw up a country, and then we can do it again tomorrow, and so on. So you've got this weird thing that this is why sort of the key emphasis I was making here is that what this is not like a new series of commodities that are being rolled out. It's actually infrastructure that's being built. Economic infrastructure. What is economic infrastructure? Just mechanisms to enable groups of people to come together and create value. And this is a technology for sharing who contributed what and who didn't, just keeping track of everything. And with payments or with registries and all that sort of stuff. But so another way of thinking of it is, it's like the invention of the company. So once upon a time there were no companies, and then in 1462 or whenever it was, there was one. Right? So the Dutch East India Company. It's like, wow, that's interesting. And what was that? Well, it was an interesting legal hack on the idea of a constitution combined with an organizational hierarchy that could move around the world and provide a shield. That's a big company, right? Turns out that's really useful for people doing stuff. So then there was one, let's make another one, 2, 3, 6. Right? How many companies are there in the world now? Who knows, right? We know how many countries there are, 192. And if there's another one, it's like, an event of the decade. But we don't go, oh, well, there's another but a new blockchain throwing these things up is more like throwing up a company that is a country. And that's a sort of laboured metaphor there, but we've never seen anything like this before. This is an innovation that, normally innovations are the sort of better, faster, cheaper, a new product, a new thing introduced into an economy. This is a new technology for building economies, but these are ad hoc, special purpose. We're going to build one for us. We're going to build one to do trade with this region. We're going to build one that's going to keep track of how lobsters move across to Shanghai. We're going to build one for making digital payments. So this idea of being able to throw up an ad hoc economic infrastructure with its own money and contracting and so on. Now, you don't need to start from scratch. You just take the source code from another one, modify it, push it out again. Right? So that's the open source methodology, which is why it's moving so fast and so disruptive.
To me, it's different, but it also reminds me a lot of the internet, and B, software itself. Which again, once you've had it's the digital. Digital technologies just have this feature that they're relatively inexpensive at the beginning to develop. The internet looks like it because of the communication part of it. Software looks like it because once you've got this tool, you can do lots of things with it, and individuals can throw.
That's why there's this sort of reference to the Internet of Value in a sense, because the new thing that's being attributed here is the notion of a value system that's being reported. And arguably you could say now all of a sudden a whole lot of computer people or software engineers and stuff have become interested in economics and accounting systems all of a sudden. Which is not bad.
To me it looks like the next evolution of the internet.
Well, it is.
It is. At the application layer, what we're talking about here is fundamentally application layer protocols. And in the sense that we're actually going on, because even in the standard network stack, the OSI stack, if you say, there was always implicit an economic, a social, and a political layer that was never really talked about. So the extra, there was actually really 10 layers. So in a sense, we get the Friendster and the Facebook and stuff, and we start to get our social layer, but we were still missing the economic layer for a large part because it was external to the system. So even the early internet, relied on effectively common pairing arrangements, and largely you had to figure out how all of that sort of worked. And the primary governance structure was ICANNs, etc., for the DNS. Now we've got a value system which is intrinsic to the actual network this time as infrastructure technology, which is at the economic layer. So it will have implications from a political layer, which is more or less the arguments around firms, markets, or governments, or more specifically the picture of inverting the hierarchy, flipping it over to be that V-shaped organisation.
But also at the moment we still need the government to enforce the rules, okay? And being a boring lawyer, but it's all ex ante, so it's after the fact. So what we can do here is prevent the wrongdoing. So quick example: has everyone here played Monopoly? Okay. Have you ever had any discussions or arguments about what the rules are? Exactly. So Monopoly is real life, okay? So you've got all these arguments, and you've got to make sure that the banker is not stealing money, and so everyone's got to do that. Okay, so that's real. And it's messy and complicated, and whereas what we're saying with blockchain is, it's like playing Pac-Man. Okay? You can't break the rules, so it's self-enforcing. So you don't need the whole of government apparatus to actually do that. But actually, part of it is some people, I think increasingly fewer, have this utopian thing that we don't need. Everything can be coded, but it can't be coded ahead of time. So dispute resolution is actually a really big thing. But the number of disputes that you need resolved is dramatically fewer because we're not arguing about whether something happened because we know that it happened. We're not trying to get money out of someone because we've already got the money. So that will go down a lot. Plus, we can start to use the wisdom of the crowds, and we can get dispute resolution down to be much cheaper.
And that's the sense in which the crucial says this is an automation process. It's not that it just magically goes away. It's that you're using machine technology for escrows or for just time stamping and so on. So we've automated those things that previously would have just been more costly because we have to go, yep, sign's done, okay, check. And it's that, this is, I sort of think of blockchain technology as just a huge push in automation. But it's a huge push in automation in a space that we've never really thought could be automated, which is governance and administration.
An interesting fact about that automation and the fact that it's open, especially the public ones, but you've also got commissioned ones as well, is they leave traces behind. The interactions, that idea of the ledger is actually recording events that happen through whatever mechanism from either the smart contract layer, which is basically the rules which part of the system, or the fact that you may have software systems interacting with the network and doing transactions. And what you're getting is very structured transactions occurring that from an empirical point of view, and if you're looking at how rules, etc. are designed, you've now got a huge amount of evidence that shows whether these things are working as you would expect. So that then creates a feedback loop in terms of how you might design those rules further. So a lot of the systems at the moment have been focused, the cryptoeconomic stuff is focused more around the mechanism design and incentive structures of how a network itself establishes. But once that becomes a base level and you start getting into these small little programs called smart contracts, how do you design those? Because now they're effectively agents running autonomously on this base layer infrastructure, and they will start to interact because that's what they're fundamentally doing, they're designing business protocols and they're interacting. So how do you actually go about designing those? How do you know that the designs reflect the implementation? And then can you get the feedback of those designs to improve them? And that's something that's just happening now-ish, just starting in terms of the areas of what's referred to as token economics, which is, okay, we've got different sets of protocols which are implemented in these things called smart contracts. They can record different accounts, whatever those accounts represent, How do they interact? What is their behaviour, and what sort of behaviour can we implement to coordinate the activities of the next layer up?
So just a little point there. The other name for institutional cryptoeconomics, which my colleagues in Austria have proposed, is just token economy. It's the idea of an economy that is built on token mechanisms.
So I'm thinking of an example. Okay, so somebody I know was once involved with a very expensive litigation, which is now old enough, so I think I can talk about it. Which is, I mean, it's 30 years old. But it was a long-term contract signed by some American firm, probably, with some Australian firm over uranium supply. And basically, prices moved on uranium a lot down. And they wanted to rewrite the contract. And I think probably there is enough complexity here for us to understand how this would play out in the blockchain world. I mean, because clearly the facts of the case we could guarantee, but they were probably in the written contract. I'm sort of wondering, what blockchain would have added to this. I mean, a better contract.
The problem with the term smart contract is the connotation of a contract being legal. Rather, it would be sort of smart rules might have been a better way of describing it. You can certainly anchor certain clauses from the legal contract or the legal systems point of view into the smart contracts running on the chain. You can certainly reduce the cost of dispute handling because you've got an evidence trail, etc. The interpretive context is an open question because lawyers don't really understand even digital signatures at the moment, let alone more complicated things like blockchains, etc., and how to interpret those. And of course, the whole point of this notion of a perfect contract is largely impossible.
Well, of course. I mean, Williamson.
Yeah.
I mean, Ollie would tell me. He lives in the house above me, by the way. Although I'm afraid he's very, very. I think he's moved into a nursing home at this point.
Right.
He's very, very senior. But yes, I've known him a long time. But he would tell you that you can't write everything into the contract, etc. My example was one where I was trying to understand whether blockchain would help because I don't think the facts are actually in dispute. Probably the lawyers were spending a lot of time trying to find justification for rewriting the contract in a context where the prices changed. But I don't think it's kind of like it was a futures contract.
One thing that you can do with contracts, though, is at the moment we have these contracts that purposely don't deal with all that many eventualities. Okay?
Yeah.
And so what they say, well, if something does occur, then we will sort it out later, which was incredibly expensive to
It's
sort
called
it
the
out.
backstop.
Except if you start to put your contracts on blockchain, which people are doing, is that you put an awful lot more time into thinking about it. And so 99.9% of them will be fine, they'll be executed automatically. And so that actually, again, another massive drop in transaction costs. And sure, you'll have the odd one to sort out, but it's a different way of viewing it.
Well, that's what I was sort of hoping, was that there would be some way to write this
Oh,
contract.
what you can also,
But that's automation you've just described.
but it's also, yes, but you've got different, it's not just saying, we're going to automate this particular contract as written, because it won't, you'll need to make other changes, but also,
So look, a good example of this is when working with the music, like the music industry is another one that's super excited about this around collections agencies. So the way you do collections agencies at the moment is that you sample. So because you just can't keep track of everything because the costs of contracting are so high and the cost of bank accounts and who owns this. So that's a situation where because it has to be done by the humans, interacting with other humans, the most best solution right now is we just sample and just hope you're in the sample. Right? So what a blockchain type infrastructure would do is basically automate a lot of those. Every time a song plays, a crypto payment goes in a registry, and it's just it just happens. Right? Now we can reserve the human interaction for disputes around it or onboarding aspects and so on. But you're just taking a process that at the moment is the best we can do given our human technologies of market payments. But it just works really, really badly for micropayments, and it also works really, really badly on a global context. Because the thing about the music industry is information good. I might write a song here and it can be played in China or wherever, and I have no idea how to get them to pay me for the 12 cents they owe me.
But as a musician, I would need somebody certifying that the software did what it was supposed to do.
All right, so now we've got
Yeah.
a new problem to solve.
Yeah,
We've got
yeah,
a trust
so I'm
problem
sort
of
of
how do we know that this is
How do
good.
you get that to
Yes,
them?
yeah.
Except at
Yeah.
the moment, the music industry is appalling. And so even if you do get some money, which most of you don't get much of it because it's all been taken out by jokers, collections,
Yeah.
agencies,
Yeah.
and largely offices,
Yeah.
it's months or years later.
Yeah.
So, I mean,
Well,
this-
I mean, the authors now get, I get the same thing now from, because Europe compels books that publish articles to pay royalties to me, even if my contract didn't specify any royalties.
Yeah.
You know, and again, it's years later.
So, I mean, but the way to think of that is this, what blockchain does is enable a whole lot more contracts. So now, instead of having, this many contracts, we've got like, thousands more. They're so much richer and deeper. And we can do that because lowering the dramatic fall in transactions costs enables vast automation. And, on net, that should be an improvement for everyone.
Oh, I agree, but I still think
Except
the
for
automation,
collections.
there's an
Yeah.
audit form.
Yeah.
I mean, I assume you can, that's part of the point of creating trust.
Yeah.
You have to be sure,
All right.
that
Yeah,
you.
fundamentally it is,
Yeah.
you've got that audit capability in the system. It's
Yeah.
intrinsic to it. And that is a key part of the technology. And at the moment, most of that audit capability is in the sense that it keeps every single a trace of all the events, aka the ledger.
So if I'm a musician, I'm going to sign up to one of these services because I'm going to get more back from it, right? And it won't be necessarily because of trust, it's because actually this particular company running this technology,
Yeah, as long as
I'm going
it's
to get
competitive.
more returns.
Yes,
from mine.
and that's the interesting thing,
Yeah.
because is this a new generation of platform monopolies that we're creating? Right?
Yeah,
So
that was-
who builds these things? Are these public
Yeah.
goods?
Yeah,
Are
I mean,
these
that's my problem.
in Australia?
Yeah.
Is it
Yeah.
Then
Yeah.
there's
It's
another
not
aspect
competitive
around
now, so.
Yeah.
the governance aspect, new types of contracts, so to speak. So if you're talking about the music industry, we're just sort of talking about attribution and then payments backwards, fundamentally a kind of simple, relatively simple accounting problem in terms of conceptual. But what about the production of that music? The experimentation, and this ties into what Jason was talking about with respect to the Innovation Commons. There's how do you know a piece of music is going to be valuable or worthwhile, and what configurations until you actually release it out there and try it out. So a lot of up-and-coming artists, for example, have to sweat it, or any entrepreneurs do, without much in the way of compensation for the activities that they're putting into. But what we've seen with the likes of Ethereum and indeed the whole ICO phenomenon is largely, while it was speculative without any doubt, it also created a huge amount of capital to actually fund projects and stuff that would not in any way actually got funding. And the ICO sort of stuff was really kind of simple based sort of crowdfunding, but types of contracts now we can go into the area of notional financial contracts that can be operating as an insurance type of contract in terms of outcomes, or investment type of contracts, not on the big scale that are typically required from the investment bank side of things, but on the micro scale, such that I can actually now create a contract that says, okay, I'm going to invest in this bit of music, that's this recording, very early on, so that I can get the upside of it later on. And because I've got a stake in that, now it's going to be in my interest to actually try and promote that bit of music. Right? So in this way, kind of amplifying the viral effect of that piece of music. But that equally applies to data and data quality. You can incentivize the curation of data through the same sort of mechanisms that these kind of governance rules allow. So we don't have to deal just with the notion of voting from a governance point of view. We've also got market-based mechanisms, which I was just talking about. We've got different types of voting, such as the quadratic voting or continuous voting in other forms. So we can start to use incentive mechanisms to effectively achieve some of the things that have traditionally been very hard to do, because we've now got this automation technology to enable us to basically automate.
And that's where we are from an entrepreneurial perspective right now. It's just like a lot of people in the space just looking at things that sort of industries and sectors, and just go, I wonder what we could do in that space now with this new space. And the answer might be nothing, or it might be completely different things. But there's a lot of entrepreneurial interest that is created by the possibilities of this technology. This is the thing that is true in every sector. So it's unclear whether we're in a bubble at the moment, or in that sense, or what we're in. But we're definitely in the early stages of a new disruptive technology, where there's phenomenal uncertainty about where this will apply, what business models it will disrupt, what current assets will massively increase, what current assets will decrease in value, what skills will be more valuable, less valuable, just a reallocation or a revaluation of resources. And that has happened incredibly quickly as well, so I think is that.
So what kind of things are you telling government, or are you telling regulators?
Well, the main thing that we're trying to get across to them is that this isn't Bitcoin. Cryptocurrency isn't what you're looking at. What you're looking at is new digital economic infrastructure and registries, and it's things that we don't normally think of as technology. We just think of them as just the base layer of how we ensure that property registries and things, just this sort of thing. That's what's just shifted. And at the moment, a lot of the mechanisms that we use to provide trust in those things, through regulation, through et cetera, those are the things that are being disrupted. Now, we don't know which ones are crucial, which ones will change, which one. There's a lot of discovery aspects to this, but the main barrier that we've got at the moment is, and we've less so this year, but the past 2 years have been quite notorious around the world on this, with some countries periodically just declaring war on us and then deciding they love it again and declaring war again. And Korea is, I'm looking at Korea on this in particular, but so China as well. But just this flip-flopping where, that we've seen this play out in the US, where different states of the US, Wyoming on the one hand, really pushing ahead, advancing, doing some fantastic things. New York tripping over its own shoelaces, and it's just you're seeing different states in the US play out very, very differently on it. So, and again, we don't normally see it. We don't normally see this happen. Regulations or sort of the role of government in the economy sort of shifts very, very slowly and predictably, and so on.
Well, the other thing from the government point of view is you've got all the regulators and all their different silos, and it's a bit like the blind man and the elephant. They see it from their little thing, and they don't realise there's this bigger picture.
So cybersecurity is seeing it one way, border security is seeing another thing. Workplace, and so everyone's. Whereas this is economic infrastructure. It cuts across all of it. That's the
unfortunate thing around the prior focus around all the cryptocurrencies and the token sort of stuff is distracted from the fact that it's actually a fundamental economic layer that we're actually created as opposed to.
Julian, So do you have any estimates of the take-up and use?
I'll repeat that just to see if we can pick it up. So that the question was, how much is this being taken up, and what level of use are we seeing?
Well, on the one hand, minuscule, in the sense that the total value of all, say, cryptocurrencies is less than it's about $500 billion, maybe, I think, would be a back of the envelope figure, which is compared to say gold, it's a tiny fraction of that. It's in terms of what is the main use of blockchain right now? It's still cryptocurrencies. Where the internet in 1992 was sort of a good description of it's often used in this sense, but I wouldn't confuse actual valuable use cases right now with the potential, with the scale of the disruption that is invariably coming on this, just simply because it cuts so deep. And the reason I'm sort of hedging a bit here is that no one knows where the specific value, what the specific uses would be. What we do know is that the current institutions we've got for managing trust are very, very expensive.
But I'm not hearing an incentive for
competition. So I'm in the export business, exporting agricultural goods out of Australia through Singapore to China. The incentive for me to adopt this technology, and actually, sorry, let me reframe this. The main barrier we've got now is that this is not a technology that an individual firm adopts. This is a technology that a network has to adopt. So if I'm a firm that's exporting beef out of Australia to China or whatever, I can say, all right, I'm going to adopt blockchain. Blockchain me up. And useless, unless all my other steps on the thing have also adopted that. So what we've got is a network adoption problem, such that in order to create value, the entire chain has to coordinate and cooperate on adoption. A chain that cuts across sectors and countries and so on. A chain that's already deeply committed to previous layers of technology and previous generations of technology. But if that process can happen, and we can expect massive increase in either profitability or reduction in price or whatever for that chain. So if we look at who is driving the adoption, it's not individual firms, it's individual sort of suppliers or processors along that value chain. It's things like IBM or Accenture, who have got the entire chain as their clients. And I'm going to sell you one, and you one, and bang, we've got it. So exactly what IBM did originally with mainframe computing as well. If they sell everyone in the chain digital computing, now this whole thing increases in value. But that could also be done by regulation, or governments could lead that, and that's what we're seeing out of Singapore is in the education sector is mandating that all education credentials have to be written to blockchain by the end of 2021, I think it is, that they've announced that. So you can have government regulatory push, you can have consultants or just tech pull, or you could have existing firms that are deeply vertically integrated can do it. So things like Tyson Foods in the US and other sort of ones that are full vertically integrated stacks and agriculture pushing it. So that's where we are right now, is that the problem to overcome isn't how do we build better tech, it's how do we coordinate adoption. And we've got regulatory barriers and we've got coordination. And the other thing is that this is also illegal, right? Because they run straight into antitrust law, basically would block this kind of groups of competitors coordinate to do a thing. That's why what we should be looking for is not where are we on the diffusion adoption curve in terms of thinking of it say as if it was say mobile phone adoption or just how many users are there, but rather to look for consortia that are effectively able to do this. Now the IBM Maersk trade lens is a good one to focus on. Ripple is kind of an interesting one around the banking sort of thing, but we're starting to see these consortia form that are based around trying to coordinate the adoption of technology across sectors and industries. So fintech is doing a lot of work in the space, the supply chain stuff. We're working with the Australia Council, which is the music funding body. They're trying to sort of push this thing across the sort of music industry. But this is a coordination problem across sectors right now.
I mean, first of all, this is nothing new, right? I mean, we've always, there have been technologies like electricity, for example.
Yes,
Which have
perfect
this
example.
coordination.
Yeah.
But I have an example for you that may be relevant for the export side. The export-import part of this, blockchains on export-import, which, are, I suspect, something that you could get a lot of gain, which is, believe it or not, I had a student whose research project was the diffusion of container shipping. Container shipping is an enormous advantage, cost advantage.
It took 30 years, didn't it?
It took 30 years.
Yeah.
I mean, at least,
Sorry.
she basically collected data on every port in the world.
When I say 30 years, it was 30 years to actually, from memory, agree the size.
Yeah. Well, yes, that was one problem, was agreeing the size.
Yeah.
But I think the push on this was competition among ports.
Yeah.
And I'm wondering in the export example whether the international importation into ports still is going to, on physical goods, is still going to require, the government has some rules, and if we have idiots in the White House, they have tariffs, and so forth and so on. And so the port has an interest in also having access to this blockchain technology on the export stuff, they might be people who could encourage adoption by multiple shippers.
So that's what we're seeing. And so
Yeah.
in Australia, with Port of Melbourne, Port of Brisbane, have both been very early adopters of this. But they need to coordinate with their counterparts as well. So what you've got is an open standards or a standards
You need an
creation
open
problem.
standard, sure.
The main, in terms of what's driving this, again, competition, but this time it's intergovernmental competition. So
Yeah.
the main thing that's driving Australia to do this is the fact that Singapore's already done it. And the main thing that's driving Singapore to do this is fear that Australia might get ahead of it. What's driving China in this is the same thing. So it's that notion that governments are realizing that they're competing with other governments to build global trading infrastructure. And this could be it's unclear whether this will be a winner take all, that will end up with just one global, probably not, that would be weird. But it's not inconceivable that could happen. And this is the way, if Singapore, if everything goes right for Singapore, which is probably the world's leading sort of blockchain adopter in terms of government, they could go from being a city-state of 3 million people to being the centre of the economic world, because of that. It's not physical infrastructure they're building; it's digital infrastructure, and that can go everywhere. So all they have to do is create the standards that others then adopt. So that's the competition.
And more at the sort of from the bottom level, I'm seeing more in terms of quite a lot of activity around data markets to basically try and solve some of the problems that Julia was talking about yesterday. To both standardise, improve the quality, to provide attribution or credit, etc., to provide the incentives to work on data sets, etc. And that's happening because of the perceived need that AI for machine learning specifically needs good quality data sets to make sense of itself. That we've also got IoT connected devices that are creating a lot of data in their own right, and so we've got to process that in some ways, and that those little sets of devices can't strictly be owned or operated by the same entity. So they're inherently network markets to begin with. So you're starting to see sort of projects that may be labelled as AI projects or IoT projects, but they're fundamentally about creating data markets of different kinds.
Just another thing on the whole area is a good book called Radical Technologies. And Radical Technologies. It's a. I was talking to someone last night, and they said you mentioned 2 books with radical in the Radical Technologies, Radical Markets, and is saying that blockchain and cryptocurrencies are the first technology that's just fundamentally difficult for otherwise highly intelligent and capable people to comprehend. And that's what it is. It's a complete, and a lot of people just cannot, they just can't get their heads around it. And that's another barrier.
Well, I think from my own experience of trying to talk about this technology for quite a while, is that a lot of the infrastructure that we rely on is invisible.
Yeah.
We don't have to think about it.
And it doesn't work very well.
But it's always not worked very well,
yes.
so we've gotten used to it.
But people don't. Yeah, they just don't. People don't realise, and I think also the young generation with their phone. I know. I've got a phone. My phone's here. I have a phone. No. But they see things happen seamlessly, and they assume that that's just things happen. But they don't. There's all these things in the background.
Wait, I mean, that's just not my view of the world. My view of the world, if it's software, it's likely not to work right. I mean, that's the thing. Actually, that's why I asked about the auditing of the music, because I mean, it's just, it's even if there's not evil people in there, you just can imagine bugs. I mean, this is why IoT I think is way overestimated, because I don't want IoT in my house. No way. I mean, how am I going to update the software?
So one of the interesting things about the blockchain space is that it's built on open source software.
Yeah, which helps.
And the thing about open source software is that it tends to be a lot less buggy than proprietary software, precisely because anyone can inspect it. And so, yes.
In principle. I mean,
Yeah,
I did actually do a research project on that once.
Well, there's
try
a
to
lot,
show that.
Yeah. So a good example I mentioned earlier about formal methods, because this idea that software is inherently broken, so we should really adopt system engineering based practices to actually try and avoid these situations, because largely when you're dealing with economic systems and stuff like that, they can be rather costly when, or in the case of the Boeing sort of situation, they can be incredibly costly to life or economically. And so a kind of inflection point that happened in 2016, I think it was our project was doing something called the DAO. It was called the DAO, to mean Distributed Anonymous Organisation, or one variant of that.
So it was Dow as in Tao, not Dow as in Dow. Not Dow as in Dow.
And this was one of the early experiments in this area around this kind of ideology which was inherent in spaces, that code is law. So whatever the code said to do was law and therefore was good. But basically, so this project was put up, it was funded to the tune of about 150 million. And then someone managed to find a bug in the code.
But they didn't actually, this is the thing, it was coded in such a way that they couldn't take it up, it was locked up for 21 days.
Yeah.
And so this was a thing, but actually they've learned from that. So one of the newer ones, I think Downstack, Genesis, what they're doing is they're not putting all the money in, it's held somewhere else. So even if it was hacked, it wasn't much that was taken. So, people learn from these things.
So code is buggy, but institutions are buggy as well.
Yes.
People would just take 10,000 years to debug them.
But as a result of that particular event, just as what Alex said, learned from it, and the practice has evolved. And in particular, now that you can put a price tag on buggy code, which was to the tune of 60 million US or whatever, it gave incentive to actually then adopt or say, how do we actually prevent these sort of things from happening in the future? How do we build better code? Now, I'm not saying that understanding is diffused right throughout the whole community, but it certainly put an emphasis on practice of formal verification.
And you can get assurance now. There's a thing called Nexus Mutual, which is a DAO, to give insurance for smart contracts.
Well,
I'm going to have to wrap up.
It's pretty clear that, banks do better at this than some other organizations. In principle, I never lost any money from my bank,
But they've had 1,000 years to get their business right.
Yeah.
Right?
No, I meant they do it.
It would be amazing
I
if
meant
in
the
2 years.
software. They spend more time worrying about it because they're more to lose.
They
Well,
get hacked all
yes
the
and no.
time. They get
Yeah,
hacked because we just don't know about it.
Arguably, you could say that
They can get
they
hacked,
shifted
yes.
risk. They shifted risk to the taxpayer in some
Yeah.
respects. Yeah.
Yeah.
Okay, I am going to have to bring this
Yeah.
to a close. Anyone got one last question? Maybe share.
Yeah, very quick, small question. How do you see Bitcoin cannibalizing the altcoins quite recently? Because at the boom, Bitcoin dominance was 40%, but now it's 70%.
The flipping thing
So
never
it's
happens,
basically eating innovation up.
No, my view on this is that no one knows. If I did know,
We would be sitting
we
here.
wouldn't be sitting here. I'd be Skyping you from my yacht. But so this is an unfolding experiment in real time. So we want to explain what's going on with this. So I think the best explanation there is that why Bitcoin is that this is like a Sheldon point. It's like if everyone thinks Bitcoin is going to succeed, Bitcoin will succeed. And the more that people think that, and the more it goes up. So again, what is that? It's a dynamics of distributed trust working itself out in real time. Banks work on the same principle, by the way. If you think the bank is safe, it's safe, as long as everyone else thinks it's safe as well. And no one's going to try and, that's why banks can not. The point I'm making here is that expectations are an important part of the story as well. And in terms of what's going on with the rise of Bitcoin versus the alts, that seems to be as good an explanation as any could have. But again, no one knows.
Okay, we've got one last question from
I want to know your opinions about Lira in terms of its effect as a currency.
And again, this is just me speaking as a I guess, an investor in a sense, but I think it will succeed. I think it will enormously succeed. So Lira, by the way, is Facebook doing crypto.
Libra.
Oh, Libra,
That's what you said,
sorry.
Libra.
No,
Yeah.
sorry, no, sorry.
Yeah,
I
but-
said Lira.
Oh.
So this is not new though. We've had private scrip before, back in the sort of 18th century and so on. The corporations would issue their own currencies. We haven't seen it for a while because it's been illegal through most of the unclear whether it's actually legal now even, but this idea of privately issued script, and that's as a thing that a large company can do. So first of all, Libra is the first one that we've seen, but it is not going to be the last. You can assume that every major social technology company is working on a project right now, and if they say they're not, they're lying. My guess is that Apple, I guess, will be the next one, or Microsoft. Anyway, so Amazon, yeah, we're going to see a lot more of this. They're competing with government script. The thing about government money is that that's the one that you're required by law to pay your taxes in, so you probably still have to do that. But so long as there's a convertible ratio between Libra and whatever you have to pay your taxes in, we're good. This limits the power of, monetary policy, that's just gone. Forget that. But that's good, right? That means we have to automate monetary policy and stable growth rules and so on. So, government money should work better now that it's got competition. I don't see this as a government money killer. I see this as a discipliner of that. The main problem we've got is, imagine a world where there's 10,000 currencies, right? That's hard for your human brain to do. But machines are fine with that. If I've got a software app that can figure it out, do the ratios, so long as we've got deep and liquid markets and all the exchanges between them, we're good. Right? So,
And no savings.
Well, you talk about liquid savings in capital. So I'm going to store my savings are going to be a whole of digital assets that are going to have,
No, but I want my savings to be correlated with the future consumption.
Define
so
savings.
I'm going to have to figure that out.
But again,
right.
define savings. Savings just means liquid asset, and money savings is mostly
Exchange rates move.
But if I've got lots of digital assets that I can convert into other sort of things, then my savings
Oh, so
or whatever.
your solution is diversification.
No, my solution is digital liquidity, and this is what
No,
digital
exchange
assets
rates
create.
move. If I care about consuming in dollars, I want my savings in dollars.
All right, so now we have to worry about stable coins, and we have to sort of add new financial markets to stabilize these things. So yes, that problem needs to be solved.
It's not, my view is the reason I don't think it's transparent that it'll work is precisely because we have a number of superinflation episodes in history which we don't yet fully understand. And so I'm worried that we don't quite have the theory to fully understand what happens when there's many.
No, that's true. That's absolutely true.
Yeah.
So,
Okay, and on that note, we'll have to call it a close. So let's thank our three panelists. That was a really energetic. And we're now, I think it's Bronwyn next.
Wait, I thought